Hello everyone. Today I'm going to be showing you in this video how to do an Arduino project involving velocity of a free fall object through a copper tube. And the reason why I chose a copper tube is because we're going to be looking at the lens effect when we drop a non-magnetic item versus a neodymium magnet. But this is the whole wiring setup here. You're going to have to use three different AA batteries. As you can see, one right there that's wrapped up in electrical tape. There's another one right behind it right there. I had to use three altogether. There's one up at the top right there with another wiring strip, but I'll show you the schematic for that on a fritzing diagram. You'll just have to solder and heat sink all of the wires together, and there's where an LED's popped out of a hole. But they're loose fit just because when we're measuring three in this, we want to be able to swap over and measure inside this one, and that makes it easy with long wires. So we'll just stick that back in the hole there. Oops. And I'll go ahead and show you how to wire this up with the fritzing diagram. I apologize for the way the camera is, but I don't have no extravagant setups to help make this any easier. But here's the fritzing diagram, and it shows two AA's. You only need one. But just wire it up to this way, and any of the wires that are going to analog, these are your detectors. These that go with the resistor to the positive strip and then the other side to the negative, these are your emitters. And in order to find out what the value of these resistors are, you're gonna have to look at the pack of whatever LEDs you're using. For instance, the LEDs I'm using are from Radio Shack, part number 2760142. But on the back, you'll see that the detectors function at an operating voltage of 1.2 volts, 1 milliamp, while the emitters operate at 1.8 volts, 50 milliamps, but we can just use 1.2 volts for both of them. That's fine. But just use Ohm's law for the emitters. We're going to use a 1200 ohm resistor, for the detector, and 24 ohm resistor for the emitter. So yeah, that's the value of your resistors here. So let's go ahead and take a look at the program now. You're going to want to run the calibration code first, and you can go ahead and pause the video. I'll just show it like this so that you can get an idea of how to write the program. But you just upload this, and once it's uploaded, you can open the serial monitor and get a reading of what the ambient light in the room you're taking the measurement is. So we got 54, 55, 64. Nothing's going below 40, so that's good. We'll just set everything to 40, all the while statements in our program, and I'll go ahead and show that to you. And again, you can just pause the video if you need to write down the program, because it'll be too long to put everything in the description. But here's the overall program from top to bottom. I'm just going to skim through this. Valve is the first sensor, valve 2 is second sensor, valve 3 is third sensor. And here at the bottom, you're going to see that FPS is in 833,333, and the reason for that is there's 10 inches between sensor 1 and 2 and 10 inches between sensor 2 and 3. So this is 0.833 feet. It's not a full foot. It's almost, but since we're in microseconds, this is 10 to the negative 6th power. So since we're dividing by a negative 6th power, we want the top number to be in the 6th power so that the units match up and we get a sensible answer. So that's the reason for that. And there's a comment section beside each line of code. You can just refer to that if you're wondering what you're writing every line for, because that can be very helpful, and if a problem occurs, you can locate it a lot easier. But this is the overall code. I hope that you can see this good enough to write it, but now then, we can just upload this, and we should be able to see waiting for free fall object on the serial monitor once it's done. It's done uploading, so it says waiting for free fall object. Alright, first I'm going to drop just some alligator clips to see if it's reading correctly here. So 1, 2, 3. Alright, it's reading. So we got 5.44 feet per second between sensor 1 and 2, and 9.22 feet per second between sensor 2 and 3, which shows that it's accelerating, which we would expect, since the acceleration of gravity is 9.81 meters per second, or 32.2 feet per second. But let's go ahead and drop a neodymium magnet and see what happens. This is going to be the lens effect. We got two neodymiums stacked on top of each other. And you can see probably right off the bat how slow it's going to go. Yeah, that's the Lenz's law there. So, let's see how fast that goes. It shouldn't accelerate at all because it can't. It's 0.10, so it should be a constant velocity. And 0.10, so this makes sense. All of this setup is definitely working and making sense with the numbers we're getting here. And other than that, you should be able to get a nice working project out of all this. Again, just when you wire this up, make it kind of loose fit. That way you can swap one wire over to the next. Unless you found a way to get 6 sensors, then you could just post them all. But this worked relatively well, and it was very easy to tote around. So if you have any questions, just leave it in the comments section, and I'll try my best to answer them.